Assalamualikum OyaRahmatullahe OyaBarakatuhu. Innal hamdanillah wassalatu wassalamu ala rasulillah. Amma ba'd. Bismillahirrahmanirrahim. This is Muhammad Kamrul Hussain, Department of Business Administration, Metropolitan University, Sylhet. Welcome to my virtual classroom, MKA CLASS ROOM. Now let's start today's video tutorial. Today we will try to discuss annuity, perpetuity and mixed stream. So today we will try to discuss three topics. One is annuity, another is perpetuity, and last one mixed stream. Now we will start from annuity. Annuity. What do we mean by annuity? Annuity is equal series of payment. Equal series of payment. Equal series of payments. Equal series of payment, that is called annuity. This amount should be equal and time intervals of two payments should be equal. Here you have to remember that amount should be equal and time intervals between one payment to another payment is also equal. Here we can see our timeline 0, 1, 2, 3 and 4. Suppose this is 4-year period. Payment should be equal, as like each year 100 taka. Your payment should be each year 100 taka. So the time interval between one period to another period is 1 year. One payment to another payment is time interval is 1 year. 1 year. Time interval one period to another period is equal 1 year. So that is annuity. So equal amount should be equal and time interval one payment to another payment time interval is also equal. This is actually annuity. And now we will try to see types of annuity. Types of annuity. Basically, annuity are two types. One is ordinary annuity, ordinary annuity, and another is annuity due. Annuity due. So we have seen that two types of annuity. One is ordinary annuity, and another is annuity due. So ordinary annuity has another name, that is called deferred annuity. Deferred annuity. Deferred annuity. Another is the ordinary annuity. Another name of ordinary annuity is deferred annuity. So, if the payment start at the end of the period, if payment starts at the end of the period, then we can call it ordinary annuity. Obviously, equal series, remember that. And annuity due whenever payment start of the time period, start of the time period, where you can call beginning of the time period, then we can call it the annuity due. So, we have seen annuity, two types, ordinary annuity and annuity due. Ordinary annuity, if equal payments start at the end of the period, then we can call it the ordinary annuity or deferred annuity. If the payment start at the beginning of the period or start of the period, then we can call it annuity due. Now, we can see an example with the timeline annuity due and ordinary annuity. That is our timeline 1, 2, 3, 4. That is the 4-year project. Two project, one is ordinary annuity, another is annuity due. We will see the example 1, 2, 3 and 4. These are the two project. It is the name of the project X and it is the name of the project Y. So, the two project, one is project X, another is project Y. So, we have told that the ordinary start at the end of the period. So, suppose it start from here 4-year project. Here we have said that ordinary annuity start at the end of the period. That means 1 year, 0 to 1, this is the 1 year, 0 to 1, this is the 1 year. So, at the end of 1 year, it begins its first installment. That is the first installment at the end of period 1. At the end of period 1, what it start for first year, first period, or you can call it the first period. At the end of first period, it starts its first payment. In the same way, at the end of second year, 1 to 2, that is the second year or second period. At the end of second period, you have provide second installment, and at the end of third year or third period, you provide your third installment, and at the end of fourth year or fourth period, you provide your last installment, that is fourth installment. So, that is the example of ordinary annuity. Ordinary annuity, we have or deferred annuity, which start at the end of the period, will start at the end of the period. So, 0 to 1, that is the period 1. Here at the end of period 1, it start its first installment. That you can give an example of ordinary annuity, that is the salary, SALARY, salary. So, those who are working in the job in the private sectors or public sectors, those who have the job, they get salary from the government or private institutions. So, that is the example of ordinary annuity, because whenever end of the month you get salary, at the end of the month you get salary. So, that is the example for ordinary annuity. In the same way, in the same example, if payment is start at the beginning of the period, that is 0 to 1, that is the period 1, payment is start from here, it is the first installment, your first installment, it is your first installment 0 to 1. Project Y, your first installment start at the beginning of the period 0 to 1, that is the period 1, 0 to 1, period 1, your payment start from first of the period. Second payment start at the beginning of second year. Third payment start at the beginning of third year, or third period, that is your third installment, and your fourth installment start at the beginning of fourth year, that is your fourth installment, that is your fourth period. That is the example of annuity due. That is the example of annuity due. So, you can see that the ordinary annuity, that is start at the end of the period, and ordinary annuity due start at the beginning of the period. So, that is the example of ordinary annuity, and this is the example of annuity due. It is the example of annuity due. So, it payment start at the beginning of the period, and example you can say that house rent, that is the perfect example of annuity due. That means you have to pay prepaid your house rent, or you can example of DPS, deposit pension scheme. You have to provide first of the month your installment, as like date 1 to 5 or 1 to 10, you have to provide of that month's installment, as like this month is July. So, you have to provide July month's installment at first of the July month, 1 to 5 date or 1 to 10 date. So, that is the example of annuity due. So, there has a difference between ordinary annuity and annuity due. That is, in ordinary annuity gets extra 1 period's interest, that is this is actually extra 1 period's interest, but ordinary annuity that is not get extra 1 period interest, because whenever you provide your fourth installment, so your that is the end of your fourth period. So, this 100 taka actually is not getting any kind of interest, because whenever your fourth period is end, then you provide your fourth installment. But in the annuity due, whenever your fourth period start, you have to provide your fourth installment. That is why these 100 taka get these periods in installment, 3 to 4, these periods in installment, but this 100 taka is not get this interest rate. That is the great difference between ordinary annuity and annuity due. Now, you have to find out the present value and future value of this annuity, that is our annuity, and we have to find out present value and future value of annuity. So, we have two types of annuity, ordinary annuity and annuity due. So, we have to calculate ordinary annuities present value and future value, and annuity due we have to calculate present value and future value. Now, we can see the formula for present value and future value. At first, future value of ordinary annuity, future value of ordinary annuity, future value of ordinary annuity. So, FVA, future value of annuity, equal to PMT into 1 plus R power n minus 1 divided by R. That is the formula for ordinary annuity. Future value of ordinary annuity, FVA, future value of annuity, PMT, payment, PMT means payment, PMT means payment, 1 plus R, R means rate of interest, R means rate of interest, rate of interest, N means number of period, minus 1 divided by R. That is the formula for finding future value of ordinary annuity. So, now we will see a future value of annuity due, FVA due, FVA due, future value of annuity due, PMT into 1 plus R power n minus 1 divided by R into 1 plus R. We have said that annuity due get extra 1 periods compounding and discounting because it payments start at the beginning of the period. That is the formula for future value of annuity due, future value of annuity due. Now, we will try to see present value of annuity. So, we have to calculate two types of value, one is ordinary value and another is annuity due. So, here we will see present value of annuity. Annuity means ordinary annuity, PMT into 1 minus 1 divided by 1 plus r power n divided by r. That is the formula for present value of ordinary annuity. Present value of ordinary annuity PVA equal to PMT into 1 minus 1 divided by 1 plus r power n divided by r. That is the formula for present value of ordinary annuity. Now we will see present value of annuity due. PVA due, PVA due, PMT into 1 minus 1 divided by 1 plus r power n divided by r into 1 plus r. That is the formula for present value of annuity due. PMT into 1 minus 1 divided by 1 plus r power n divided by r into 1 plus r. That is the formula for present value of annuity due. So now here we have seen that annuity, types of annuity and calculating mechanisms for present value and future value of annuity and annuity due. Now we will talk about perpetuity. Perpetuity. Perpetuity means the endless annuity. Whenever annuity is not end, but or it is continue forever, that is called perpetuity. That is continue forever. Continue forever. That will run in the long time or never end. This annuity is called perpetuity. A stream of equal payments expected to continue forever, as like 100 taka payments, but it is not end here, it could be continue forever. So it has a formula to finding present value of perpetuity. Here we have to calculate only present value, PV of perpetuity. Only we have to calculate present value of perpetuity. Here PMT divided by R, interest, payment divided by interest. The formula for present value of perpetuity PMT divided by interest rate. Perpetuity can be instructed. Perpetuity can be instructed by British securities that were issued after the Napoleonic Wars. In 1985, the British government sold a huge bond issue and used the proceeds to pay off many smaller bonds and that were issued in prior wars to pay for the wars. Because the purpose of the bonds was to consolidate past debts, the bonds were called console bonds. That bonds are called console bonds. So, console bond, a perpetual bond issued by the British government to consolidate past debts, in general any perpetual bond. As like here as an example, what would be the bond be worth if the opportunity cost rate or discount rate was 5%? Discount rate was 5%. So, here has an example we have to see what would be each bond, what would be each bond be worth if the opportunity cost rate or discount rate was 5%. So, here has the problem. What would each bond be worth if the opportunity cost rate or ordinary rate is 5%? If suppose each console promised to pay 100 taka per year in perpetuity, what would be each bond be worth if the perpetuity cost rate or discount rate was 5%? The answer should be 2000. So, here we have a CPVP equal to each year payment should be 100 per year, 100 taka per year, 100 taka per year, and our interest rate is 5%, that means 0.05. Then answer should be 2000 taka. The worth of this console bond is 2000 taka. Another example in here, suppose the interest rate increased to 10%, what would happen to the console's value? Suppose interest rate increased to 10%, what would happen to the console's value? The value dropped to 1000 taka. So, we can see PVP, present value of perpetuity, equal to 100 divided by rate of interest increased by 10%. So, here the value is 1000 taka. Actually, these are the problem of perpetuity, endless annuity. Now, we will see mixed stream. Mixed stream where you can call the uneven cash flows, uneven cash flow streams were mixed stream. So, here has also the two types of value, uneven cash flows, that means where the amounts are not equal, Now, you can see by an timeline 0, 1, 2, 3, 4. Each year payments are different, 100, 400, 600, 700. So, these payments actually different year by year, all are a single amount, and each year payments are different. This actually the mixed stream or uneven cash flows. So, we have to again calculate mixed streams present value and future value. We have to calculate again present value and future value of this mixed stream. So, that is easy to calculate. So, each year's amount are different. So, you can use a single amounts formula to calculate this value. So, that is why you have to calculate the value of n. So, in the previous example, that is we are using 1, 2, 3 and 4, 100, 400, 600 and 700. The example of mixed stream. So, you have to calculate its future value, then value should be in this way, future value at the end of year 4, at the end of year 4, what would be its value, what would be its value, what would be its value. 100 taka, what would be its value of after 4 years, 400 taka, what would be its value after 4 years, 600 taka, that is a project. Here you are getting this amount, 100 taka amount, 400 taka amount, 700 taka amount, 600 taka amount. So, these are the project, as like the name of this project X. You are getting this amount for the several years. At the end of first year, you are getting 100. At the end of second year, you are getting 400. At the end of third year, you are getting 600. At the end of fourth year, you are getting 400. 700 taka. So, what will be the value after 4 years? So, that is easy to calculate. So, you are using formula, future value formula, F equal to PV 1 plus R power n, because each walls are a single amount. So, if you add with this value, then you can calculate the future value. In the same way, if you calculate this amount, the future value 1, 2, 3 and 4, 100, 400, 600 and 700. So, you have to calculate its present value, then the timeline should be left side. Remember that by the timeline, whenever you are calculating future value, timeline should be go through left to right, left to right, left to right, left to right, and whenever you are calculate the present value, timeline should be right to left, right to left, right to left, right to left. So, and you can use the formula, single value formula, present value equal to future value divided by 1 plus R power n, and these are the equal is single amount. You are seeing that is the single amount. So, if you add with this amount, then you can get the total future value 1 plus R power n. In the same way, future value PV into 1 plus R power n. So, that is the first year, second year in this way. That is why you have to determine the value of n, then it is easy for you to calculate. Then again we can see 0, 1, 2, 3, 4, 100, 400, 600 and 700. You are going to calculate future value by the 100 taka. What would be the value of n? Suppose the rate of interest is 10%, no problem. So, these 100 taka carries value of n 1 period, 2 period and 3 period. So, n should be 3. Now taka 400. What should be the value of n? 1 period and 2 period. N equal to 2. 6. The value of n equal to 1, and at the end of 4th year the 700 value of n equal to 0. Now you can put your formula PV into 1 plus R power n, FV equal to, so you can each single amount you can add with this your amount, as like 100 into 1 plus 0.10 power 3 plus 400 1 plus 0.10 power 2 plus 600 1 plus 0.10 power 1 plus 700 1 plus 0.10 power 0. Then if you calculate by your calculator, then you will get the result. By the calculating from my calculator, result is that 1977.10. By the calculating from my calculator, the result is 1977.10. Now again we see that our future value formula equal to PV 1 plus R power n. So that is the formula for our future value. So this is our future value. Now here again single amount formula 1 plus R power n, that is our use of formula. Again we will see PV 1 plus R power n, that should be in here, and plus PV equal to 1 plus R power n, that 700. So here PV is for 100 taka, here PV is for 400 taka, here PV is for this 600 taka, and here PV is for this 700 taka, and the result of our future value is 1977.10 taka. And again we see the value of n from here. This 100 taka carries in here 3, n equal to 3, 400 n equal to 2, 600 n equal to 1, and 700 n equal to 0. In this way we can calculate future value of mixed stream. Now present value of this mixed stream. Here we will again draw our timeline 0, 1, 2, 3, 4, 100, 400, 600, and 700, that our previous examples. So, our required interest rate is 10%. So, here we will see the calculating present value timeline will be get right to left, right to left, right to left. So, 100 here 100, what will be its value of n? 1 to 0. So, you have to come at time 0, because this is the present value. At the present value value convert this value at time 0, that is the present value, we know it very well. So, what will happen? 1 to 0, n equal to value is 1, then 400, it carries the value of 1 period and 2 period, n equal to 2, then 600, it's carry the value of this 3 period, n equal to 3, 700, it carries the value 4 to 3, 3 to 1, 1 to 0 and 2 to 1 and 1 to 0, n equal to 4, n equal to 4. Then it is very clear to us the value of n. Now, we can use our desired formula P v equal to F v divided by 1 plus r power n, that is our formula for a single amount. So, here we have several single amount, 100 divided by 1 plus 0.10 power 1 plus 400 1 plus 0.10 power 2 plus 600 divided by 1 plus 0.1 power 3 and 700 divided by 1 plus 0.1. Then if you calculate by your press your calculator, then result will come as like you can calculate 100 divided by 1 plus 0.1 power 1. Divided by 1.1 power 1, 90 taka, 90.91. 400 divided by 1 plus 1 power 2, 330.58 plus 600 divided by 1.1 power 3, 450.79 plus 700 divided by 1.1 power 4, that should be 478.11. Then total present value should be 90.91 plus 330.5 plus 450.79 plus 478.11. From my calculator, it shows the result 1350.39 taka or 39. This is our total present value of this problem. So, here again we will see this 100 is here. If you show in here again 1 plus 1 power n, that is for 400. So, and now here we will see that 1 to 0, that is the period 1, 1 to 2 or 2 to 1, that is the period, another period, 3 to another period, 3 4 another period. So, in here 100 carries the value of n because 1 to 0, 400 that is 2 to 1, 1 to 0, 600 3 to 2, 2 to 1 and 1 to 0, and 400 700 3 to 4, 4 to 3, 3 to 2 and 2 to 1, 1 to 0, that is n equal to 4. In this way we can solve our present value of mixed stream problem. In this way we can solve. So, it is clear, very much clear that in this way we can solve our mixed stream of present value. Now, again we will see our an example of annuity problem. So, we are not doing any kind of an example for annuity. So, we will now see the problem of annuity. So, again we have to remember that if it is annuity due, then first payment should be in here, then the 100 carries the value of 0. Remember this. If here is a problem of installment is the first date, if says the installment at first date, then this 100 should be in here and the value of n should be 0. The same way, if the problem says that first installment start at time 0, but very starting time, then it carries 100 in here and the value n should be 4. The value n should be 4 because 1, 2, 3, 4, that is all our time problem. This should be remember that if such type of problem arise, if not arise, then it is not, but if arise the problem, then you can do in this way. So, we see the previous examples 0, 1, 2, 3, 4. Here our payment 100, 100, 100 and 100, that is our payment. So, our rate of interest rate is 10%. What will be its future value? What will be its future value. If you use the formula, it is okay, no problem. You can use a single formula for calculating this amount. Otherwise, you can use the timeline problem. You can use timeline to solve this problem. So, what will be our future value? F V A. Our problem is that PMT 1 plus R power n minus 1 divided by R. That is our formula we have learned in this previous sections, because it is the ordinary annuity. Annuity is the ordinary annuity. It is the ordinary annuity. So, we can use only the payment, 100 taka payment, 1 plus rate of interest 0.10, power should be 4, because that is our 4-year project. So, power should be 4 minus 1 divided by 0.1. Then we can show our result by use of calculator. 1.1 power 4 minus 1 divided by 0.1 into 100, that is 464.10. 464.10. That is, if we use this method formula, then our result is 464.10. But again we can solve this problem by the use of timeline. 100, 100, 100 and 100. If we use our timeline in this way, we can use our timeline. So, what will be the value of n? N equal to 1, 2, 3, this 100 equal to carry 2, 1, 0. Then you can use future value equal to 100 into 1 plus 0.1 power 3 plus 100 1 plus 0.1 power 2 plus 100 1 plus 0.1 power 1 plus 100 into 1 plus 0.1 power 0. Then what will be our result? By the pressing calculator, our result will show 100 into 1.1 power 3 plus 100 1.1 power 2 plus 100 1.1 power 1 plus 100, that is 464.10. The result is same. So, you can use any other method, or you can use these two methods to solve this problem. So, that is our timeline methods problem, solving our problem timeline method. So, or you can use this formula at a glance to solve this problem. So, that is the future value of ordinary annuity if it is annuity due 0, 1, 2, 3, 4. Annuity due payment start from here. Payment start from at time 0. Then we know the formula F V equal to P M T into 1 plus R power n minus 1 divided by R into 1 plus R, because that is the formula for annuity due. Annuity due. Then we can use our method 1 plus 0.1 power 4 minus 1 divided by 0.10 into 1 plus 0.1. So, what would be our result? Result should be 510.51. 510.51. And this problem you can use the timeline method. 100, 100, 100, 100. So, timeline method. So, this here n should be 4, 1, 2, 3, 4. N should be 3, 1, 2, 3. N should be 2, 1, 2. N should be 1, 1. So, that is our fourth payment. So, you can solve in this way. Future value F V equal to 100 plus 1.10 power 4 plus 100 1 plus 0.10 power 3 plus 100 1 plus 0.10 power 2 100 1 plus 0.10 power 1. Then you can calculate it by your calculator, and result should be 510.51. 510.51. So, in this way you can solve the annuity problem by timeline method and by the using of formula method. So, here we see the future value of ordinary annuity and future value of annuity due. Now, we will see the present value of annuity. Present value of annuity, we will use the same formula to better understand of our problem. So, 100, 100, 100, 100 and rate of interest is 10%. So, what would be the present value of this amount? So, we know the formula for present value formula PV A, that is the because it is the ordinary annuity, PVA equal to PMT into 1 minus 1 divided by 1 plus R power n divided by R. That is our formula to finding present value of ordinary annuity. So, in our problem we can use this formula 100 into 1 minus 1 divided by 1 plus 0.10 power 4 divided by 0.10. So, what will be our result by the pressing our calculator? 1 divided by 1.1 power 4, result 1 minus this result divided by this result bhag 0.1 into 100, 316.98. So, you can solve by your calculator. It is, you can see what should be the result. So, again I can press my calculator. 1.1 power 4, answer 1 minus answer, then divided by 0.1, 3.169 into 100. So, 316.98, 316.98. You can do this problem by timeline method. You can do this by your timeline method. What will happen? That should be present value in right to left, right to left. So, this 100 should be n equal to 1, n equal to 2, n equal to 3 and n equal to 4. Then what will be our present value? 100 divided by 1.1 power 1 plus 100 divided by 1 plus 0.1 power 2 plus 100 1.1 power 3, 100 1 plus 0.1 power 4. Then you can press it by your calculator. What would be the result? 100 divided by 1.1 power 1 plus 100 divided by 1.1 power 2 plus 100 divided by 1.1 power 3 plus 100 divided by 1.1 power 4. So, again the same result. 316.98. So, the result will be the same if you do it by the timeline method or by the formula method. You can use any one of these, which one will be benefited for you. You can use this here. So, we will see present value of annuity due. Present value of annuity due. Annuity due payment start at time 0. So, we know the formula PVA due equal to PMT into 1 minus 1 divided by 1 plus R power n divided by R into 1 plus R. So, we know the formula for present value annuity due, PMT into 1 minus 1 by 1 plus R power n divided by R into 1 plus R, because that is the annuity due which get extra 1 year compounding and discounting. We know it very well that due takes extra 1 period compounding and 1 period discounting. Whenever we calculate future value, it takes 1 period compounding. If we find out present value, it takes extra 1 period discounting. Then what will happen to our value into 1.1? So, 348.68. So, value should be greater than ordinary annuity. If it is present value, obviously it is the greater amount than ordinary amount of future value. If we calculate the present value, annuity due would be obviously greater than ordinary annuity. So, if we do this problem by our timeline, then we will see the matter 0, 1, 2, 3, that is the end of our value. So, you can see here, here and here. So, what will be its n value? This 100 takes the value of 0, this 100 1, n equal to 1, this 100 n equal to 2, this 100 n equal to 3. Then what will be our present value? 100 divided by 1 plus R power 0, 100, 1 plus 0.1, 1 plus 0.1 power 1 plus 100 divided by 1 plus 1.1 power 2 plus 100, 1 plus 0.10 power 3, and result should be 348.68. You can calculate by your calculator, and if mismatch your result, please comment in my video. I think it should be no change our result from the formula and from the timeline method. So, here actually today we have learned the annuity, solving the annuity problem Then we have learned the perpetuity, solving the perpetuity problem. Then we have learned the solving the problem of uneven cash flow or mixed stream cash flows. Today we have learned today. This all about today. Stay home, stay safe, try to maintain a safe social distance, try to wash your hands frequently in a day. Subhanaka Allahumma wa bihamdika ashhadu an la ilaha illa anta astaghfiruka wa atubu ilaika. Assalamualaikum warahmatullahi wabarakatuhu.